Alright, 8th graders, today we're talking about multiplying polynomials. So your essential question is, can you multiply two binomials? So we're only going to talk about binomials, which means there are two terms. So x plus 3, there are two pieces, and x minus 2, two pieces. So it's a binomial times a binomial. We remember that when we're multiplying can be represented by parentheses mashed up against each other. So the first thing that I want to tell you is that you should always write your answers in standard form. So that's largest exponent to smallest exponent. You may have to rearrange things after you multiply them out. Now, we're going to use the FOIL method today, and FOIL, I'm going to write this over here and eventually erase it, but FOIL stands for first, outer, inner, and last. And FOIL is one of the things that oftentimes people remember about algebra, but don't remember how to use it, when to use it, what it is. It's just one of those, like, I don't know, maybe it gives people bad memories of high school algebra class, but a lot of times when you say, I'm taking Algebra 1 or Math 1, people will say, oh, I remember how to FOIL, or I remember doing FOIL. So, it's a classic. Doesn't mean you're going to love it, but it's a classic. So, FOIL, so you see that we have first. So, you're going to multiply the two things that are first in your equation, or in your two binomials, the first thing in each binomial. In this case, x times x, which gives us x squared. The next thing you're going to do is multiply the outers. I'll pick different colors. So we multiply the outers. So this is the outside edge and the outside edge. X times negative 2 is negative 2x. The I stands for the two inner pieces. So we have positive 3 in x, which is positive 3x. And then finally, the L stands for last, and my lasts are 3 times negative 2, which gives me negative 6. Now, we can combine like terms. So in this case, negative 2x plus 3x. X squared doesn't have anything to combine with. Negative 2x plus 3x is 1x. And then minus 6 for our final answer. So when we multiply, let me just show you another way to look at this. We do, I often draw the rainbows. So first times first, outer, wrong, first times first, outer, inner, last times last. So FOINL. Alright, let's look at this one using FOIL. I'm going to use the rainbows this time again. So first times first, 2x times 2x is 4x squared. And then we have outer, so outside edge to outside edge, 2x times 1 Then we have inner. So we have negative 1 times 2x, which is negative 2x. And then we have the lasts. So last and last, negative 1 times positive 1 is negative 1. So I can combine 2x minus 2x. Those cancel. My final answer on this one is 4x squared minus 1. This is basically like a giant distributive property. So you can see you're doing 2x times both pieces and negative 1 times both pieces. So just one step further complicating a distributive property, but you're still multiplying 2x by everything over here and negative 1 by everything over here, and then combining like terms. Another way to multiply two binomials is using a table. I don't care if you use FOIL or table. You can do whichever one makes you happy. There's no wrong way. So I take x and 2 and fill them in down here. 2x and negative 1, fill them in over here. And then in the center boxes, we write down when we multiply the two things. So 2x times x is 2x squared. 2x times 2 is 4x. Negative 1 times x is negative 1x. Negative 1 times 2 is negative 2. And then we combine like terms. So in this case, we would combine 4x and negative 1x. So we have 2x squared that can't be combined with anything. 4x minus 1x is 3x. And negative 2 for my final answer. Again, if you like the boxes, you may use them. If you like FOIL, you may use that. X times negative x is negative x squared. X times negative 2 is negative 2x. Negative 3 times negative x is positive 3x. Negative 3 times negative 2 is 6. I want to combine like terms. So I get negative x squared plus 1x plus 6 for this one. Now, if you wanted to check by using FOIL, we can do that. Negative x times x, negative x squared. Negative x times negative 3 is plus 3x. Negative 2 times x is negative 2x. Negative 2 times negative 3 is positive 6. Notice your 4 things in your box are your 4 things that you're multiplying. And then here you're combining to get your 1x. You get your same answer. Alright, moving on to the next section. Just says find each product. You can use tables or FOIL. I use FOIL because I'm lazy. I don't like to draw out all those boxes. Kind of the path of least resistance. This letter E though is a good one because there are 3 terms over here. We have a binomial times a trinomial. So it's the same thing. If you think distributive property, you're multiplying x by all 3 sections. So x times x squared is x cubed. X times negative 3x is negative 3x squared. X times negative 2 is negative 2x. And then we're doing the 5 times all 3 pieces. So 5 times x squared is 5x squared. 5 times negative 3x is negative 15x. And 5 times negative 2 is negative 10. So we have x cubed, which doesn't combine with anything. Negative 3x squared and 5x squared make 2x squared. negative 2x and negative 15x make negative 17x, and then the negative 10 can't combine with anything either. So our final answer is a polynomial to the third degree, x cubed plus 2x squared minus 17x plus 10. Here's another one. N times n squared is n cubed. N times negative 2n, negative 2n squared. N times 4 is 4n. Negative 3 times n squared is negative 3n squared. Negative 3 times negative 2n is positive 6n. Negative 3 times 4 is negative 12. We want to combine like terms. So n cubed stays, 2n squared minus 3n squared, negative 2n squared, and negative 3n squared makes negative 5n squared. 4n and 6n make 10n minus 12. G and H are written a little bit differently. You remember that exponents just mean that we have two of this thing. So x minus 2x times x minus 2x is the polynomial that I'm talking about. So I can multiply those out. X squared minus 2x squared minus 2x squared plus 4x squared. And here we actually end up with all x squareds. So we have 1, and we have 4 negatives and 4 positives, which cancel out. So 1x squared is my final answer. One mistake people tend to make on these is they just want to say that this answer is 4x squared minus 9. It is not. Do not just square both things. That is incorrect. You actually have to write the whole thing out. I hate it for you, but you have to write out the whole thing and then FOIL it, or it will be incorrect. 2x times 2x is 4x squared. So you might say, Mrs. Martin, it's right so far. But 2x minus 3 is negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. So your correct final answer is 4x squared minus 12x plus 9. Do not fall into the trap. If you have multiple things inside parentheses, you have to write those out and FOIL. Alright, distributive properties, like I said, it's really the same as foiling. So why don't you try these four for homework on your own, and then we'll go over, you guys can do 5 and 6 also, and we'll go over number 7. You go to a movie theater 2t plus 3 times each year and pay t plus $7 each time, where t is the number of years after 2011. Write a polynomial that represents your yearly ticket cost. So 2t plus 3 is the number of times you go, and you pay t plus $7. So your yearly ticket cost is going to be, I mean, this is the yearly ticket cost, but it doesn't fit the description right as a polynomial. So to write this as a polynomial, we have to, oh, that's a t, we have to multiply it out. So we get 2t squared plus 14t plus 3t plus 21, and if we combine like terms, we get 2t squared plus 17t plus 21. And your yearly ticket cost in 2014, where T is the number of years after 2011, so T would be 3. I fill in T is 3, so 2 times 3 squared plus 17 times 3 plus 21. If you type that exactly into your calculator, you'll get the correct answer. 2 times 9 is 18. 17 times 3 is 51. 18 plus 51 plus 21. 90. $90 you spend going to the movies in 2014. Alright, try those ones in the middle there for homework, and we'll check them tomorrow. Have a great night.